In this video, we will practice some organic chemistry questions from your CIE's paper October-November 23. So let's start our paper. So here is the question number 6. Ethanol is manufactured by two methods. Method 1, fermentation of aqueous glucose, and method 2, catalytic addition of steam to an alkene. We have learned both of these methods in our previous lectures. Let me recall it one by one. In method 1, we basically used a living cell called yeast. So the cells of the yeast breaks this glucose molecule in an anaerobic conditions into ethanol plus carbon dioxide. And the second method to prepare ethanol is the addition of steam to an alkene. We are supposed to make 2 carbon alcohol, ethanol. So we should use 2 carbon alkene, that is ethene, for the catalytic addition, and we're gonna add up steam into that. So we can see this whole water molecule gonna add up into this ethene molecule. This double bond, it would be broken down. Consequently, each carbon would need to add up one more thing, one more reagent with it, because carbon is supposed to make 4 bonds. So hydrogen will be added up over here. This water molecule also gets split up between hydrogen and oxygen, and the remaining OH, this one, it would be added up over here. So here we get ethanol. So this is a second way of preparing ethanol, but this method must be done at high temperature and high pressure. State 2 other conditions that is needed in method 1. In method 1, first of all, we need yeast, and secondly, we need to provide anaerobic conditions in the absence of oxygen. Let's move to the B part. State the typical temperature and pressure used in method 2. As we have discussed just now that we need high temperature and high pressure. So the temperature gonna be around 300 centigrade and the pressure gonna be around 6000 kilopascals. Second part says name the alkene used in method 2. We were supposed to make 2 carbon alcohol. So obviously we had to use alkene which is having 2 carbon. So the name of that alkene is ethene. Third part, state why the reaction in method 2 is referred as addition reaction. Here you can see in this reaction that we had 2 components, they added up with each other and they give us one product. So that is the reason we consider this reaction as addition reaction. So the answer gonna be we only get one product. So that is its addition reaction. The C part says catalyst in method 2 is phosphoric acid. Dilute phosphoric acid is a weak acid which contains phosphate ions. State what is meant by the term acid. We learned in Bronsted-Lowry concept that an acid is a species that can donate proton. Second part says state the meaning of weak in the term weak acid. We have learned in acid base concepts that the weak acid is an acid which do not completely dissociate into its ions. For example, if we have 10 molecules of an acid, we have 10 molecules of phosphoric acid over here. So might be 2 or 3 out of 10 would dissociate into its ions. Remaining molecules would stay as phosphoric acid in this form. So weak acid is an acid that partially dissociates into its ions. Contrary to weak acids, if we discuss about strong acids, so the strong acid gonna be that acid whose molecules completely gets ionized into its ions. For example, if we have 10 molecules of an acid and 10 out of 10 molecules get dissociated into the ions, that acid gonna be referred as strong acid. So let's move to the next part. The next part says determine the oxidation number in the phosphate of the phosphorus in phosphate ion. It's very easy to find out the oxidation number of any element in a group, as we can see the whole phosphate group carries -3 charge. So we're gonna write it like this, -3. Let's start assigning the oxidation number of oxygen in this group. One should, you should be very clear in your mind that oxidation number is basically the possible charge on that element in a molecule. So how we can calculate the possible charge on that element? It's very easy. You just need to find out the position of that element in periodic table. Let's say if we start calculating the oxidation number of oxygen, we can see that oxygen belongs to group 6. So it's going to have 6 valence electrons. So for each oxygen, in order to complete their octet, each oxygen requires 2 more electrons to complete its valence shell. So after gaining 2 electrons, each oxygen going to carry -2 charge, and here we have 4 oxygen, so -2 multiplied by 4, that going to be -8. So what charge we should put on phosphorus? So the overall charge should be left as -3. For example, we have the resultant -3, we have -8 on oxygen. So what charge we should put on phosphorus? So overall we should get -3. That's very easy to find out. That's gonna be +5. So the resultant would be -3. The phosphorus carries +5 charge. So the oxidation number of phosphorus is gonna be +5. Let's move to the next part of the question. Give one advantage of each method of production of ethanol. Let's say the first method, that is the fermentation. The one of the most biggest advantage of fermentation is that it's very, it's a renewable process. You can keep adding the reactants, you can keep supplying the nutrients to the yeast, and yeast keep, breaking down the glucose into the ethanol. And if we discuss the advantage of method 2, that was the addition of steam into the ethene, that this method gives us high production of alcohol, because let me show you. In method 1, this method only gives us 16% ethanol, because yeast cannot synthesize more ethanol, because here we have a living thing in this system. And if the percentage of ethanol is exceeded from the 16%, it becomes toxic for the yeast. So the yeast start dying. So we can only get the maximum efficiency up to 16%. But the method 2, there is no biological species involved in this method 2. So we can obtain a very high purity of alcohol. So the advantage of method 2 gonna be more concentration of ethanol could be obtained. Let's move to next part. Ethanol can be converted into ethanoic acid reacting it with an acidified oxidizing agent. We have learned this reaction, that how an ethanol it could be oxidized into ethanoic acid. We need to we have to use acidified KMnO4 for this reaction. So these two carbon alcohol will be oxidized into 2 carbon carboxylic acid. So that gonna be ethanoic acid. So that's the ethanoic acid. So let's move to the question. Name the acidified oxidizing agent. That is KMnO4. State in term of redox what type of reagent ethanol is in this reaction. We can see that ethanol is being oxidized into the ethanoic acid. So the thing which is being oxidized into an acid, so it acted like a reducing agent, because we know the reducing agents are the agents which actually gets oxidized but they reduces others. So here in this reaction ethanol acted as reducing agent. Next part, ethanoic acid react with calcium to form a salt and one other product. Name the salt. First of all, you need to understand ethanoic acid is an acid. So this is a typical reaction between acid and metals. We know whenever we react metals with the acids, it always gives us salt plus hydrogen gas. So we used to name the salt C double bond OH plus calcium. So it gives us CH3 C double bond O. So this is the salt which would be produced by reacting ethanoic acid with calcium. So the name of this salt gonna be calcium acetate, because this is the acetate ions. These are the acetate ions being attached with calcium. So we name this salt as calcium acetate. Or we can also call it calcium ethanoate, because this thing is also called as ethanoate group. Calcium ethanoate. Let's move to the second part. Write the formula of the salt. So we already mentioned the formula. Let me write its formula. So they're going to be 2 ethanoate groups with 1 calcium. Next part, identify the other product, that is hydrogen gas. So that's all about the question number 6, organic chemistry question from October November 2023. I hope you have understood these concepts.